Alright guys, welcome to the second video on complex numbers, video 1.2, and this video we're going to be covering conjugates and division. So we're going to start out a little bit boring. First of all, we're going to cover some basic definitions. So the definition of a conjugate of a complex number. So let's say we have a complex number, we're going to call this complex number Z, and we'll say that Z is a complex number. And it can be whatever complex number you want. It could be like 1 plus I, it could be 8 minus I, it could be anything you want. We just say it's going to be any complex number. And we're going to define the conjugate of Z. So that's Z with a little crossbar at the top. We're going to define Z bar as the conjugate of Z. So this will be the conjugate of Z. So that's the term. So Z with the bar on top, that's the conjugate of Z, and Z is just any complex number that we defined. So what exactly is the conjugate? So the conjugate is basically if we have, let's say we have Z is equal to some real number A plus some real number B times of I, then the conjugate of Z is simply A minus BI. So basically you're just flipping the parity of the sign in between the real and the imaginary parts of Z. So let's say that if Z is equal to A minus BI, then we know that the conjugate of Z would just be A plus BI. So whatever the sign in between the complex numbers are, we're just going to reverse that parity to find the conjugate. So how does this actually relate to division? That's a very good question. We're going to show that right now. So we're going to go to some division. Alright, so let's just cover some base rules here. So let's say we have Z is equal to A plus BI, and we're going to say that W equals to X plus IY. And we want to find what is the value of Z over W. So what is the value of this? So if we write it out a mathematical term, it would be Z over W equals to A plus BI over X plus IY. So that would be our Z over our W. So notice here, we have our I, which is the imaginary part, in our denominator. And we don't like that. So what we like, what our mathematicians like, is when we have a complex number, we'll call this complex number B, and we say B is A plus BI. So we like to have no complex numbers on the denominator. So the question is, how can we get rid of the complex number on, complex imaginary part and the denominator? Now that's a very good question, and what we do something that is called, we multiply by the conjugate. Remember, we define our conjugate as the reverse parity of the sign of the original complex number. So whenever in math, whenever you don't want to change something, so you can multiply by 1, it's not actually changing anything. So let's say we have 4 times 1 is 4. We have 6 times 1, that's 6. So if you multiply by 1, you're actually not actually changing the expression, it's just 1 lot of that same expression. Since we don't actually want to change the value of Z over W, that's what we're trying to find, we don't want to actually change it. So what we actually want to do is we actually want to multiply by 1. But you might be asking, it's pretty useless to multiply A plus BI over X plus IY by 1, that's just going to give us the same thing, right? Well, there's a way we can strategically multiply by 1 in order to change the form of Z over W to get it into this form, which we all like, you know? And that's what we call by multiplying by the conjugate. So if we have Z over W equals to A plus BI over X plus IY, when I say multiply by the conjugate, I mean we are simply multiplying by the conjugate of whatever's on the denominator. So this is a complex number, X plus IY. So the conjugate is simply going to be X minus IY. So we're going to multiply by X minus IY on the top and the bottom. So let's just expand this like any algebraic term. This is going to give us on the top, we're going to get AX minus AYI plus BXI. And we have BI times negative YI. The negative and the I squared will cancel each other out. So this is just simply BY. And this is all over. Let's expand the bottom. We have X squared. And we have minus XYI. We have plus XYI. And we have Y squared. As you can see here, we have negative XYI and positive XYI. So that's just going to get rid of that. And this is just going to be AX plus BY minus AYI plus BXI all over X squared plus Y squared. So do we actually change the expression? Well, the answer to that is no. The reason we didn't change the expression is because we multiply by 1. X minus iy divided by x minus iy, that is 1. This is just multiplying by 1. So basically, we're not actually trying, we actually can just write this as the answer to z over w. But however, like I said before, mathematicians like it in the form of a plus bi. So we're just rewriting this expression in that form. All right, so that's pretty cool. Let's go through some examples. Okay, go through some examples here. So we can go through some examples. All right, so let's say we have z equals to 1 plus 2i. We have w equals to 3 minus 4i. We want to find what z over w is. What is z over w? So first step, we're going to write out our expression. So we have 1 plus 2i divided by 3 minus 4i. What's the conjugate of 3 minus 4i? Well, that's simply 3 plus 4i. So we're going to multiply it by 3 plus 4i on the top and 3 plus 4i on the bottom. And from video 1.1, you should be pretty comfortable with this now. We're going to multiply the complex numbers. So we have 3 plus 4i times 1 plus 2i. 3 times 1 is 3. 1 times 4i is 4i. 2i times 3 is plus 6i. And 2i times 4i is negative 8. And we divide this by 3 times 3, which is 9. And negative 4i times positive 4i is positive 16. So you might be wondering why I just skipped the middle part where you multiply to get the complex terms, the imaginary terms. The reason I just skipped that part out is because, remember, as we saw in this page, we see that our complex part, I keep saying complex, it's imaginary parts on the denominator keep cancelling out. So we actually we can just properly ignore that part. We don't even need to go and expand that, so we can save some time. So we're just going to go and simplify this expression. 3 minus 8 is negative 5. 4i plus 6i, that is positive 10i, and that's all divided by 25. And now we can simply just simplify this expression. It's pretty simple. Negative 5 divided by 25, that's equal to negative 1 over 5. And 10i over 25, that's actually pretty simple as well. 10 divided by 25 is 2 over 5i. See, and here, that is our final answer. That's example number 1. We'll go through one more example. We'll say example number 2. We'll just go through another pretty simple example. We'll say z equals to, we'll say 8 minus 4i. We'll say that w equals to, we'll just say 2 minus I. All right, so we're just going to follow through our steps again. So z over w equals to 8 minus 4i over 2 minus I. And we multiply by the conjugate. We can speed things along now. The more practice problems you do, the faster you can get. And speed is pretty important. And if you want to get your exams finished under the 3-hour mark. So 8 times 2 is 16. 8 times I is positive 8i. Negative 4i times 2 is negative 8i. And I times negative 4i is positive 4. Divided by 2 times 2 is 4. And then negative I times I, that is 1. So 4 plus 1 on the bottom. So we're going to just simplify again. 16 plus 4 is 20. And we have 8i minus 8i is 0. Divided by 4 plus 1, which is 5. And that's just 4. All right. So I hope that gave you some little bit of background into dividing complex numbers and rewriting it in the form of a plus bi. And I hope from this video you can take away, so the takeaways from this video. So after this video, you should be able to understand what a conjugate is. And we should be able to perform basic division on complex numbers. Alright, I hope you enjoyed this video, and I'll see you in 1.3, which will be talking about Argand diagrams and coordinates.